Okay, in this finding the time to reach a limit in a word problem on exponential growth or decay, if you look at the explanation, they kind of have you guess and check this. So I'm going to show you both things, like the guess and check, but also because we're rapidly closing in this section on how to actually solve exponentials, I'll show you how to do that too. Also, it's interesting to see more than one way. And also, if you're going to guess and check, definitely use your calculator to your advantage. So this one says a car is purchased for $34,000. Each year it loses 20% of its value. After how many years will it be worth $7,200 or less? Okay, so picture when we've set these up previously, there's always a starting value, which in this case is 34,000. And then if something's losing 20% per year, it means it's retaining or keeping 80% of its value. So it's quicker, right, just to multiply by 0.8. So if you want to say how much will it be worth at the end of the first year, it's 34,000 times 0.8. At the end of the second year, you would multiply by 0.8 twice. And by the end of the third year, you'd multiply by 0.8 again. So if you're noticing a little pattern there, what would be quicker is we could say each year you multiply by 0.8. So it makes the unknown here, or the variable, the exponent. So the more years that go by, the more times you multiply by 0.08. And we're asking, when will this be less than or equal to $7,200? All right, so the first thing they suggest in here is just try some values. Say like, after 5 years, or we can divide both sides by 34,000 just to make it a little bit less. You can plug the whole thing in your calculator. Sometimes if you're just plugging in your calculator, you could also graph it and see when it goes below 7,200. So essentially they're just kind of guess and checking it. And they find out that it looks like 6 years is too many. Save some time not going to the calculator part of it. So 6 years is too big. And 7 years gives you less than 7,200. And so you say, oh, well, after 7 years, because you're trying to give them a whole number answer. All right, so if you're at the point where you don't like guess and check and you're kind of over that method, I will show you what you can do to actually solve for it. So one thing, we're trying to get t by itself. So we could divide both sides by 34,000, right? This is multiplied here. And 7,200 divided by 34,000 gives us 0.2117, right? It has more decimal places, but we'll round at some point. All right, so now we're at the point where we need to get something free out of the exponent. So we could do one of two things. We could rewrite it as an exponential like we did in the original definition of a logarithm, and we could say log base 8, or 0.8, sorry. Log base 0.8 of this 0.2117 number equals t, right? The answer from a logarithm. Or if you want to use the logarithms that you're going to have a button for on your calculator, right? Because then you could just use this if you have the log base thing. Another option is you could take any log. You could do natural log or log base 10 of both sides. Don't want to lose my decimal there. You could take any log of both sides and use that property that an exponent out here becomes multiplication out front. And so now this says t times natural log of 0.8 equals natural log of 0.2117. And then divide both sides by natural log of 0.8 to get the t by itself. And so regardless of which way you do it, notice if we say t equals this, or if we said earlier, I had to make some room by erasing, log of base of 0.8 of 0.2117. See how that looks like change of base formula? Like these two things are the same as each other. So it actually doesn't matter which way you want to think about that. You'll eventually end up at some nice answer for t. And then you can just go ahead and put that in your calculator. Pull mine up right now. Definitely not something you can do off the top of your head. Natural log of 0.7 divided by gives you 0.695-ish. T t equals 6.9577. So maybe rounds up to 6.96, or in this one, after where they said after how many years does the value, then you can say, oh, well, it's almost 7 years, so it takes at least 7 years to get below 7,200. 6 years, it's still a little bit above 7,200. So a couple options. If you click the explanation, they'll show you guess and check because you haven't learned all these skills yet, but you've learned enough that you can solve it. So dealer's choice on whether you want to guess and check or just solve those ones.